The discriminant is one of the powerful tools in understanding the roots of quadratic equation. We know that in a quadratic equation, we can determine a maximum of 2 roots, and we can use this discriminant to determine the type of the roots or the nature or the behavior of the roots, whether they are actually real or imaginary, or whether they are equal or unequal. Let's consider the standard form of a quadratic equation, ax squared plus bx plus c, where we can determine a, b, and c. And using these coefficients and this formula for a discriminant, we can plug in here the values for b, a, and c, and whatever will be the result will tell us the type of roots for each of the given quadratic equation. If the discriminant b squared minus 4ac is greater than 0 after plugging in all the values for b, a, and c, we can now say that our roots are both real and unequal or distinct from each other. If the discriminant or the value of the discriminant is equal to 0, our roots can be real and they are of the same value. In short, since there are 2 roots or maximum of 2 roots, for a discriminant be equal to 0, there's only 1 root with multiplicity of 2. And if the value of the discriminant is less than 0, then we can assume that our roots are imaginary and distinct. I'm using here the term distinct rather than unequal because since they are imaginary, let's just simply use a word appropriate for the imaginary numbers, which is distinct, meaning they are not the same as well. Let's try to consider this given expression, x squared, or equation, x squared plus 3x minus 10 equal to 0. We know the values of a, b, and c are the following. A is 1, b is 3, and c is negative 10. So plugging in all of these values without knowing or using all of these processes for the roots of that equation, and if we would like to determine immediately the type of roots, simply use the discriminant, b squared minus 4ac, plug in the values, and the result will tell us that our roots for x squared plus 3x equals, minus 10 equals 0 are both real and unequal because 49, the value of discriminant, is greater than 0. Now on our channel, we have a lot of examples that will also tell us the type of roots if the given discriminant or the resulting discriminant is less than 0 and equal to 0. And there are also examples where our a is not equal to 1 for more explanations. So please try to view them on your own time.